Now in this next chart, we see the entirety of the evolutionary timeline in an interesting circular chart that is linear in scale. So the Earth began about 4.5 billion years ago, 4.55 billion years ago in fact, and life began shortly thereafter. But all these basic processes of life took billions of years to occur. The entirety of the time since the formation of the Earth to the present is this circle extending from this starting point, 4.55 billion years ago, all the way to the present, and the accelerating rate of change is very evident in this chart. And here we get a new perspective about how recently major advances have occurred. So since the start of the Earth, the first life was a good 500 million years plus after that point. The first photosynthesis was 1.35 billion years after the Earth began, and this was photosynthesis in the ocean, mind you, not on land. Other very basic advancements occurred until you get to this point, and as you can see, that is 88% of the way until the present. So if the beginning of the Earth was here, only here, 541 million years ago, do you get the Cambrian explosion, where the diversity and complexity of life rose considerably, but was still very primitive by today's standards. The most advanced creatures were trilobites and other non-vertebrates. Vertebrates came later. The first vertebrate land animals are signified by this yellow line. Dinosaurs are signified by this red zone over here. So not even the entirety of the Mesozoic, but well into the Mesozoic, a good 30 million years or so into the Mesozoic, is when dinosaurs began. So the entire duration of dinosaurs was over here. And hominins, which are not even modern humans, but proto-humans combined with modern humans, have existed for 2 million years, which looks like a very, very insignificant amount of time out of the 4.55 billion years of the Earth's existence. Under the accelerating rate of change, you can see how much time it took to get to very primitive life forms. Again, 88% of the Earth's total existence is what it took to get to the Cambrian explosion 541 million years ago. Dinosaurs are much more recent than that still. Now, if you're interested in my paleontology masterclass that has taken the form of Elon Musk's semantic learning tree, you should look at this video up here in the upper right hand corner. However, if you're watching this Data University series as a playlist, don't interrupt your playlist to go to that. You can go to that later on. But this chart is an interesting representation of the accelerating rate of change, which began with the beginning of the Earth. There's an accelerating rate of change evident even in human history, as I describe in other videos, as well as in the age of civilization and in economic progress, which I also describe in other videos. And that is one of the primary themes of this channel. But evolution as a timeline, this perspective as signified by this arrow, the direction of time, tells us how recently the major vertical movements in the accelerating rate of change have occurred, and how even the extinction of the dinosaurs 66 million years ago was very recent relative to the beginning of the Earth. And all post-dinosaur life forms only exist in the Cenozoic period. So again, the accelerating rate of change is evident over here. Thanks for watching.